Hello again, let's review d by dx of the sine of x squared. Let's employ the chain rule. That's d by du of the sine of u times d by dx of x squared, where my u term is the x squared here. So now d by du of sine of u is just cosine u. D by dx of x squared is 2x. Yeah, what we've got is cosine of u times 2x, but it's just more elegant to write that as 2x cosine u. By commutativity, I put my 2x in front here. And then, so that's going to be 2x times the cosine of x squared, and we're done. Of course, from the very get-go, from the beginning, we've let u equal x squared, okay? Again, that's just more chain rule going on. This is a review. And now d by dx of the cosine of x squared, we're just doing the cosine instead. You go through the same motions. Now, if you derivate the cosine, you get negative 1 times the sine. But you can just yank the negative sign out in front. And, oops, I made another mistake. That needs to be sine, doesn't it? Sorry about that, guys. So that's sine of x squared there. So, yeah, so it's negative 2x times the sine of x squared. And I'll put a space between that for elegance. Okay, so there's that. And so everything else is good. And then now, if in a similar manner, I do the tan. I just go through the same motions. Remember, the derivative of the tangent is the secant squared. I don't remember if I showed that earlier or not. I might have, possibly, but I don't recall. But you can, if I didn't, just take, you can, if all else fails, just take my word for it. D by du of tan u is the secant squared of u. That, you can just take my word for it. You can prove it with limits, but just take my word for it. We may or may not have proven that earlier. I don't recall. But anyway, and then the 2x comes out of the chain rule. And then in a likewise fashion, just recall the derivative with d by du of secant u is sec u tan u. And in a similar manner, the d by du of cosecant u is negative 1 cosecant cotangent. And just keep all this stuff handy. Memorize these trig rules, guys. They're handy to have. And d by dx of the cot of x squared, again, recall, if you derivate the cot, you get negative cosecant squared, or negative 1 times the square of the cosecant. And I'll leave it for you to do this one on your own. So again, this is just a review. And another chain rule, d by dx of the sine of e to the x. You just let u equal e to the x and do the chain rule right here. And then you just get e to the x times the cosine of your original e to the x. Now this one is a more difficult example. If you ever have the sine fifth of like x to the sixth, remember that's the same thing as the sine to the fifth power, so it's just the sine of entity x to the sixth. And we're taking the sine of, we're taking x, raising it to the sixth power, then taking the sine of whatever that is, and then we're raising whatever that turns out to be to the fifth power. In that order, by the way. So now by the chain rule, I'm going to let u be my outermost operation, which is raising something to the fifth power. I'm going to let my intermediate operation be, which is naturally the sine. That pretty much has to be. I'm going to let v be my intermediate guy. U is going to be my sine of x to the sixth. V is just going to be my x to the sixth itself. And then finally we go innermost, d by dx of x to the sixth. And then, now guys, what's going to happen here, d by du of u to the fifth is 5u to the fourth. D by dv of sine v is cosine v. D by dx of x to the sixth is 6x to the fifth. And then, now that 6 and that 5 multiply into each other to give you the 30. I just, by commutativity, I bring the x to the fifth over here. Here's the u to the fourth. It doesn't matter. You can put the u to the fourth in front of the x to the fifth. It doesn't matter. And then here's the cosine of v. You could put any particular term in front of the other. This is an elegant way to write it, though. And then you just substitute back in. Now u is the sine of x to the sixth, so u to the fourth is the sine fourth of x to the sixth. That's what the sine 4 means, right there, sine to the fourth. And then, now I've got my cosine of v, but now v is x to the sixth, so cosine of x to the sixth. Okay, now I revisit another example. Now, this is a cousin to one I did a while back. Now we got those 3 cosines, but instead of a nice little x in here, we've got x squared, okay? Well, what you got to do is you'll let u equal cosine of a cosine. That's kind of like we did before. And we'll let v equal the cosine of x squared. V is kind of like it was before. Instead of cosine x, it's cosine x squared, though. Now, we got to do a third guy, though. When we just had x in here, there was no need to let w equal x. That would have been silly. But, well, yeah, it would have been silly. But anyway, but what I've got here, so I let w equal x squared, and I get, so I've got, remember, this is the outermost, so we do d by du of this cosine of u, which is the u is just the cosine of x squared. So we're doing, this is the cosine of all this stuff is u. And then so d by du cosine u times d by dv cosine v. Now, the v is just the single cosine of x squared. And then d by dw cosine w is just the x squared itself. Okay. And then finally, we got to go in and do d by dx of the x squared. Okay. So there's that. And so what we have is now that, this is going to be 2x when we derivate it. So we bring the 2x in front. We get a negative sign, negative sign, negative sign. And then, now that's not very elegant. Let me create a little space there, guys. Sorry about that. That's very unelegant. So putting a little space there. Now 3 negatives will leave you negative, so we bring that in front as a multiplier, just a negative, an understood negative 1 multiplied. So we have negative 2x sine u sine v sine x, and then just plug back in for u and plug back in for v, okay? That one was another one that was a little more challenging, but I just wanted to do a good little review. And that I did, and also in the review, d by dx of e to a polynomial power. Well, that's just d by du of e to the u. I'm going to let u equal that polynomial and do the chain rule. D by du of e to the u times d by dx of that polynomial. And this rule would hold even if this was not a polynomial. Like if this was a cosine up here, I'd just put that cosine here. But anyway, getting back to this problem. So here's that. And then now by the chain rule, d by du of e to the u is e to the u. And then d by dx of this guy, well, just you remember you just derivate them term by term. The sum of the derivatives, the sum of the derivatives is the derivative of the sums. So we just do d by dx of 4x squared, that's 8x. D by dx of 5x is 5, and d by dx of 6 is 0. It's gone. So we just have 8x plus 5, and you got to put a parenthesis around it because we're multiplying the whole thing by e to the u. Now you could put the e to the u in front here to the left if you'd rather. Either way, I just kind of found it a little more elegant maybe over here, but it doesn't matter. You can put it here to the left side of the 8x plus 5. Be sure it stays outside the parentheses though. All right, but then you just go in and plug that polynomial back in for u. So just plug this 4x squared plus 5x plus 6 back in for u, and you're done. Okay. And down here, I do a d by dx of this cosine here. Guys, again, you just let u equal that polynomial and do d by du. Instead of e to the u, it's cosine u. And so, but we still, our u is still the same u. We're just doing the cosine instead of the e to the power of. And if you derivate cosine, you get negative sine, or negative 1 times the sine. You just put that negative out in front and go about your business. And there you go. And guys, I'm going to stop the video here, and we'll move on to another video. Thanks. I'll see you on the next video. Bye-bye.